Here's a hint on the bicycle cadence problem. The bicycle cadence problem is the one where you have an ideal cadence of 90 cycles per minute, but you'll accept anywhere between 80 and 100 cycles per minute as being close enough. So the question is, how do you measure cadence? How do you measure cycles per minute? And typically on a bicycle, what you have is some kind of a sensor, maybe a magnetic switch, that every time a magnet goes by, the switch closes. So if I plot the switch closing as a function of time, maybe the switch when it closes gives a voltage, a 5-volt signal to one of your input pins. So on your microcontroller. So let's say we're looking at the voltage on one of the input pins, and as the pedal goes by, so the voltage is low, but then when the pedal goes by, it jumps up to 5 volts. And then it stays high as the pedal passes, and then at a certain point the voltage drops back down. The switch opens back up, and the voltage drops, and so then the voltage stays low until the next time the pedal goes by, and then the voltage jumps up again, stays high, and then drops down, and so forth. Now what we're looking at here is something called a periodic signal. And periodic signals are characterized by a couple of things. One is their frequency, and the other is the period. Okay, we're going to use the letter F for frequency. We're going to use the letter capital T for period. So the period in this case is the amount of time from one point in this waveform to the identical point in the next. So, for example, the period here, T, would go from here to here. So this would be one period T. Okay? So the relationship between frequency and period is this. The period is 1 over the frequency. So I'm bringing this up because cadence, for example, 90 cycles per minute, is a measure of frequency. But what the microcontroller is good at is measuring time, and period is a measure of time. So what we want to do then is we want to figure out the period that's associated, for example, with 80 cycles per minute. So we know that period is 1 over F. So if we look at the frequency of 80 cycles per minute, we'd have 1 over 80 cycles per minute. Okay? Minutes are in the denominator of the denominator, which is the same as the numerator. So this would be 1 minute per 80 cycles. Okay, so the period then is measured in terms of time per cycle. Okay, the microcontroller doesn't measure minutes very well, but it does measure seconds. So we're going to do a little unit conversion here. We know that there are 60 seconds in a minute. So we can cancel minutes, and we wind up with 60 over 80, or 0.75 seconds per cycle. Okay? That's the period associated with 80 cycles per minute. That winds up being actually the maximum period we would expect to see, or that would be acceptable. The minimum period, so the T min, would be the one associated with the highest frequency, which would be 1 over 100 cycles per minute times 60 seconds per minute. Cancel minutes, and we wind up with 0.600 seconds per cycle. So that would be the minimum period. Okay, so anywhere between 0.600 seconds and 0.75 seconds would be an acceptable period. Now, how do we measure period? Well, harken back to the problem you just did on the reaction timer, where you're measuring time, and you're measuring the amount of time you keep your finger on a button and the amount of time it's off. And so that's what we're going to look at. If you look back at this period, T, notice that it's a combination of when this button is on, so we'll call this T on, and the amount of time when the button is off, so T off. So T is equal to T on plus T off. Well, these are things you can measure. So what you can do is you can have the microcontroller wait until the button gets pressed, and then you sit there and you measure the amount of time the button is pressed with T on. Then when the button goes off, when you take your finger off the button, you continue to measure T off until the next time the button goes on again. So that would give you both T on and T off, and that would give you a period. As long as that period is between 0.6 seconds and 0.75 seconds, you're in the safe zone. The next thing I would recommend then is that you have maybe have 3 LEDs, maybe a green one in the middle, which means that you're okay, a red one when you're going too fast, which means the period is too small, so red means maybe slow down or something, and then yellow might mean speed up, so that would mean that the period is too long. So that's about as good of a hint as I can give you on the bicycle cadence problem. It's an interesting problem, not trivial.